Hello, ladies and gentlemen. This is Sid. I hope you're well. And today we're doing another little Golang tutorial, a fun little one where we're going to be writing a terminal user interface application, or TUI. And I love terminal interfaces. I think they're fun. They're really useful. They can be, you build applications that do something, and they're usually cross-platform, so they usually run on Windows, Mac, and Linux. And you can build little UIs that do the work without having to worry about pulling in a big user interface framework or something that's big and heady and clunky. You can just do a quick and dirty little application like we'll do today. So let's have a look at what we can build today. So let's run this little thing that I have already. Let's slide on it. And what it is a very silly application that basically goes out and fetches a random Chuck Norris joke from the internet and displays it in your terminal. And it updates every 10 seconds at the moment and fetches a new joke. So here it says, when Chuck Norris falls in water, Chuck Norris doesn't get wet, water gets Chuck Norris. And then we display the time of when we actually fetch the joke and a little bit of flair around it, right? And this is just a terminal application. You can see it's just going inside my terminal here. I can move it around. And this is really handy. So what I want to show in this demo is basically how you can build your own terminal application like this. And one thing I liked, or the reason I chose this example, is that often in our terminal applications these days, we want to do something that interacts with the World Wide Web. We want to pull some data from the internet. We want to do something that is connected because terminal applications are great. But these days, everything is connected and in the cloud and so on. So I wanted to show you how you can build an application that actually uses that. So let's start with the actual library that we're going to use, or the package that we're going to use in Go. So I like the Tview package. It's a great little library that is quite actively maintained and used in a lot of projects. You may know it from something like K9s. If you would any kind of Kubernetes work or any kind of cloud deployment work, a lot of people use K9s. It's a great little terminal application. So that was what we've been using Tview. And it does a lot of stuff. So we're only going to be touching on some very basics today, but I wanted to make you aware of how to use it and how to get started. So let's get started. Let's bring up Newbim and have a look. So the only thing I've done so far is I've pulled into Tview itself, right? And I've just said there's a top-level app, which is appointed to an application, and then I've instantiated an application. And right now it doesn't do anything. If we were to run this, nothing would happen. So what we're doing with saying new application to create an app, and then we're basically calling app.run after having set a root of the app. And a root is basically any kind of UI element that can make up this application. So as an example, let's start with a really simple example. Let's create a text view, right? So Tview, so text view, text view, like so. And all this does is literally create a text view that can render some text. Now, the text view has a couple of properties that we can set. So we can start by setting something like set dynamic colors. This will allow us to actually use color syntax inside the text. We can also say it should wrap text when it actually handles text. We can say set word wrapped true. There's a lot of properties that you can look up in the documentation. But more importantly, let's do two more things. We'll set the text alignment, which is always good. Let's align it center. So we'll say tju.align center, to align to center. And then finally, let's actually set some text. So let's say hello world from Tview. All right. So that's our text view, and now we can actually set that as the root of our application. So now we should see when we compile and run this, and for once I'm actually not going to run it directly in Newbim, because we obviously are building a terminal application, so let's run it inside a proper terminal. Let's build our application, and then if that works, let's run main. And there we go. Now we have a blank Tview application that says hello world from Tview. Cool. So we could add multiple text views, right? And we can add more text and we could build the little application this way. If we add some more text, run up again, there we go, it's updating. Great. But like I said in the start of the video, normally what we want to do is we want to make it a little more interesting. And one would make it interesting in an application like this is to have a worker thread or another thread that does some background work and then had the main thread that's running application here displaying the result. In other words, let's turn it into a concurrent application that actually is able to do a little bit more than just put out static text. So how are we going to do that? Well, two things. Let's start by creating a text view top level pointer here that we're going to store. Again, we could do this with injection if we did it properly, but for the sake of this example, let's just store the text view pointer to the text view at the top of our application here in the top scope. And then if you think about what we want our application to do is we want it to go out and fetch a joke, right? So let's say get and draw a joke. This is a function that we're going to be creating, and we'll hold off a bit on actually fetching the joke. Let's just say fetch Chuck Norris joke from the web, right? That's the work we actually want to do. And then we want to update our UI with the joke, right? And this is the thing we'll implement first. So how do we do that? Well, we created this text view top level pointer, and we have an app top level pointer as well. So there's a couple of things we can do. We can start by calling textView.clear. What this will do is it will actually clear whatever is in the text view at the time so that we can add in our new data that we've got. And now the text view, interestingly, implements the IO writer interface in Go. So what we can actually do is we can actually just use FNT, so our standard beloved FNT library, to basically write something to that writer stream. So we can say FNT print line, for example, and you can see this takes a writer, IO writer, and we can just pass in our text view, and we can say hello. But rather than saying hello, let's make it a bit more interesting. So let's just give it the most recent time. So let's create a time string, and that time string, we're just going to format a string here. This is all very standard Go. The only thing that's a bit different is we're going to give it a color. Because we've set dynamic colors to true, we can actually use this handy little color syntax to basically specify font colors. So let's go ahead and say gray. And then we're actually going to pass in the current time. So we'll pull in time as well, and we'll say now, and then let's format it to something that's a bit more interesting to look at. So we'll format it based on this RC here. So let's go in and pass in the time string. Great. So now we've defined a reason we'll get and draw joke. It doesn't actually do like it. It just grabs the current time and writes it to a text view. But we're not calling it yet. It's not doing anything yet. So how do we actually make this happen? How do we get it to update our application? Well, let's go ahead and create a little refresh. Let's say refresh joke helper function. And what this will do is this will actually implement a time ticker that will do some work on an interval. So if you're not familiar, the time library has a cool little utility called a ticker. You can say new ticker, and you can give it an interval to tick at. So to make it a bit interesting, let's do it every 5 seconds, right? So now we can implement a tick, and tick, actually, this little utility from the time library has a great syntax, which is very similar to channels. So I've done a video on channels on this YouTube channel. But in this case, take it from me that it's very similar, and you can do something like this. You can actually say, whenever the ticker ticks, so you say case, tick.c, we want to do something. What is it we want to do? We want to do two things. We want to get and draw a joke, right? And finally, this is not enough. We need to tell the application to actually refresh itself. So that's why we have this top level pointer to the app, because we can now call app.draw. So go ahead and format this. So what does this do? Well, there's two things happening here. So first of all, we're obviously calling this function here that grabs the latest time and writes to the text view the latest time. And then we're calling app.draw. Now, there's a really important thing here, which is that the app.draw function in the Tview library is so-called thread safe. So we'll say this through this whole application or this whole documentation is that app.draw is thread safe. That means that you can call it on different Go teams, and it will basically behind the scenes figure out how to render your app correctly, so that these threads don't get in each other's way. So they've implemented some stuff in the background to allow us to call app.draw from different Go routines. So with that in mind, we can actually go and invoke refresh joke from a Go routine. So we're going to say go refresh joke. So what this will do now is it will kick off this refresh joke function, which if you look at it is actually a ticker, but just sits there and ticks and basically runs this forever until we tell application. And what we'll do every tick, it will get and draw the joke, right? So let's see if all the stuff we've written there works. So we'll go ahead and go build. And we've got hello world from Tview, right? So we don't know if anything works yet, but there we go. The timestamp just came in. So 5 seconds passed, the ticker ticked for the first time. And now if you look at the timestamp, every 5 seconds, it's actually ticking again. Great, right? So now all that remains is for us to do something every time it ticks. So let's go ahead and do something. And that something is fetching a Chuck Norris joke. So obviously this is where you would plug in whatever you want. Again, the Tview library is very powerful. It has a bunch of cool stuff. You can build very complicated applications. We're not going to do that. We're going to build something really silly, but uses chucknorris.io, which is a free JSON API that I found that allows you to fetch a random joke. So for example, they use like a JSON syntax, so you can hit jokes at random. When Chuck Norris was born, the whole hospital cried. But you can also give it a category, which I quite liked. So you can give it a category, and one of the categories, for example, that they have is science. So the science ones are a bit more interesting. Let's go ahead and implement this. It's very straightforward. So we can see in the JSON here, put it with the raw one, whatever is easier for you. You can see it has a value field, and there's a bunch of other stuff in there. Great. We could fetch like the little icon, which would be fun. But no, let's just do the value for now. And the value is the actual joke. So with that in hand, let's go actually implement this. So we won't go in this for this whole thing in too much detail because we've done HTTP requests in Go before in other videos. But for the sake of this video, we're just going to create a payload struct that has a value. And this is the thing that we'll be unmarshalling the JSON to. And then we're going to use the trusty HTTP library in Go to actually go and fetch some stuff. So HTTP, we're going to pull it in, and then we have the get function, right? Now, what do we need to get? Well, we'll just copy the URL from here. We'll go in like so, and we'll paste that in. So now we're far enough like an HTTP GET request to this URL, and we'll get back either an error or the result. So let's check if the error is nil. And it is not null if there's an error. For now, we'll just panic, right? We're not going to handle this gracefully. We're just a little terminal application. If we crash, we crash, right? It'll be fine. We could handle this more gracefully in the future if you wanted to, but let's not get bogged down in them. And if it doesn't fail, we should be able to extract some bytes from this result that came back. And the way that works is you pull in the IO library and you call readall, for example, on the result.body. Again, we're not going to go into detail, but the big takeaway here is that the result.body implements io.readCloser, which is a Golang readCloser implementation. So we can call io.readall to get a stream of bytes from it and read those bytes out. Again, we'll handle an error in case something goes wrong. And now finally, we have some bytes, so we can actually try to unmarshal them into our struct. So let's go ahead and create the payload struct instance, like so. Payload. And let's try to unmarshal into it. So we'll see error equals JSON. We'll pull in our trusty JSON library encoding.json. And we'll pull it in and say unmarshal. Right? Unmarshal. And then we'll say payload bytes. And we're going to try to unmarshal them into payload. And again, if something goes wrong, we'll just throw a big panic. And that's someone else's problem. Now, that's really all we have to do. Because now we should have, if this all goes well, we should have a payload struct that has a value, but it's the actual joke. Let's go ahead and add that to our text view. And again, the text view is just a stream where we can add multiple print lines to it if we want to. So we can just say, I'm going to print line to the text view. And what I'm going to do is I'm going to print line, valuing to it. And then just to make it a bit nicer to look at, we can add some new lines before our timestamp. Cool. Let's try it out. So we'll go ahead and build our application. Again, hello world from Tview. Great, right? Let's see what happens when it starts ticking. Boom, there we go. We now have a random Chuck Norris science joke come in every 5 seconds, and we have a little timestamp that tells us when the joke actually occurred. So that's really the sort of crux of this application. That's really how this application works. The rest of it is really just extra fluff that we can add. Let's do a couple of things just to make it a little bit nicer. We'll increase the time to 10 seconds, just because reading those jokes in 5 seconds can be a bit hard. We can also there's a lot of things you can do with the text view. We won't, again, get bogged down. But let's set the text color. That's always fun, right? We can set the text color. And then the Tview library uses a T-cell dependency library to control colors. So you can say something like colored lime. I quite like a colored lime. I think that looks good. Like so. Let's go ahead and run that. Oh, actually, before we run it, let's do one more thing. As you saw there, it starts with this hello world from Tview. We don't really need that, right? We don't really want that. We just want it to go straight into a joke. So we don't have to wait for our ticker here to actually call our get and draw joke. We could just call it once ahead of the ticker and say start the application by giving them a draw and a joke. And then when the time comes, the ticker will tick and it will fetch us hopefully a new one. Let's go ahead and run this and see what happens. And there we go. Chuck Norris can divide by 0. That's a big start to this. Let's just wait 10 seconds and see what happens. Another factor, science fact, roundhouse kicks are comprised primarily of an element called chucktanium, right? So now it's running and it's fetching a new joke every 10 seconds, right? So what is this actually good for? I think these little kind of applications are really useful, especially when you start diving into the Tview library itself. So what I will do is I will put onto GitHub in a repo the code to the full little example that I showed you at the start of the video. So you'll see how to add additional things. But a shout out into the Tview wiki here. This is kind of where you can see how all the different things work. So when it comes to adding multiple elements, they have a grid control that allows you to control the layout of your application. You can also use a flex control, which you're more used to kind of like a flex, like a responsive kind of layout. It's really quite an in bold library and also has things like pages. If you want to do navigation, you could build quite a complicated application to do whatever you needed to do. Again, without worrying about big UI frameworks that take a lot of time to learn, right? This is all quite simple and straightforward. And it's quite bare bones in the sense that you're close to it in the Go code. You can really write something simple. But I think this pattern is good because you can actually have a background worker that does something like fetch an HTTP request and then use the data for something. I think that's something that a lot of these example applications don't have, is they don't have the concurrency model that allows you to do something like this. So I hope that was useful for you, and I hope you build some cool terminal applications in Go. Again, I'll put the link to the repo with the demo code for this video in the pinned comment below. And I hope you have fun with this and let me know in the comments if you built some cool terminal applications. All right, thank you very much, guys, and I'll see you in the next one.